All right, hey there. We are going to do question 8. Now, question 8, what is the deal with question 8? Well, question 8 is all about having a mystery method where you don't really know, it doesn't tell you by the name what it does, but you have to look at it and see what's actually going on with this thing. So let's take a look at the question here. Like mystery, the question is, let's have a look here. Oh, there we are. So mystery, the function is taking a number as an input. It has an array of numbers as well. It's going through that array. Whenever you see a for loop and an array together, it's a pretty good indication that you're going to be doing some traversing of that array. And this is doing that, but it's going backwards, starting at the end and going backwards. It has a condition inside. If the value that we're looking at from the array is less than the number which we had as input, then return the k, and k is the index that we're using to go through the array, right? So it's going to return the position of that number that was less than the input number. Otherwise, it's going to return 1, negative 1. Right, so we have to choose for this one. If we run int m equals mystery n, it's saying which is the best description of that, what's going to happen. So I would suggest doing this to, firstly, you could look through each option here and you get confused, or you can just eliminate the ones which are clearly wrong. Now you notice here with the method is that it's exiting straight away, so it's exiting early. If it finds any number that's less than the number input, it'll return. So that's the first thing to notice. So here, all values in position 0 through m are less than n. Is that guaranteed? Well, it's not in any particular order. It's not a sorted list, right? So the list doesn't have any order. So I would say that's clearly wrong, right? You don't know what's in position 0 because this might exit early. It might exit as soon as it finds a smaller number. So I wouldn't think that's true. All values in positions m plus 1 through numbers length minus 1 are less than n. Are less than n. Well, if it finds a number that's less than the input, it will exit. So all numbers must be greater than number, right? Because otherwise, if it finds one that's less than, it's going to exit. So all numbers m plus 1 through numbers length minus 1 are less than m. No, I would say that that's the opposite. It should be more than. So here, the next one. All values in positions m plus 1 through numbers length minus 1 are greater than or equal to n. I would say that's the best answer for this one. D wouldn't be true. Like the smallest value is a position m. Well, you wouldn't know if it's the smallest. It might be smaller than n, but it's not guaranteed that it's the smallest one. And the largest value that is smaller than n is at position m. Also, you don't know. When it says the largest and smallest, you don't know that because it's exiting as soon as it finds a smaller value. So you don't know what's in the rest of the list if it exits early. So I would say best chance answer is C. And we're right. All right, let's go. Next one. All right, next one is question 9. We also have another mystery method, okay? So these are just ways to get us to try and guess what's happening in the array. So let's have a look. What are the concepts involved here? Well, mostly the concepts that we have working here are that we're trying to look at these standard array types and standard use of loops in order to find things. So there are certain algorithms that are using traversals, right? So we run through the array, we run through it, and we are doing something, like we're computing up the sum, we're getting the average, we're finding if there's one is bigger or one is lower or something like that. Like, it's always this kind of pattern. And this question is kind of similar to that. We're looking for a pattern. So we have mystery here, and it takes an input as an array. We have an array as an input, an array of integers. And we have a count here. And here we have a current, right, equals array length minus 1. So that's the value that's at the end of the array. The value that's at the end of the array. Here we have an enhanced for loop, so we know that we're cycling through the whole loop, right, the whole array. So if the value, right, the value to each item that we're looking at, if the value is greater than the current value, then count equals count plus 1. Else, count equals count minus 1. And then current equals value. So current gets updated with the value. So what is this doing? I mean, this is a bit of a weird algorithm. Firstly, it sets the value to the last item. Okay, and then, so for example, like, let's look at this example here. It sets the value of current to the last item there. It says, now, it goes through the array and says, if this value is greater than this value, then add to the count. Otherwise, we minus the count. And now we set the current to this value. And then we keep going, the next loop. Next time we check and see, is this one greater than this one? Add to the count. Yes, we're going to add to the count this time, right? So, does it make a lot of sense? No, but you have to just work through it. And working through it will help you to try and figure out what's printed as a result. In this case, let's see, it's basically saying if the value is bigger than the current value, right? So, as it updates the current value each time, we can see that we're going to be adding 1 here if this is greater. So if this is greater, if this value is greater than this value, we're going to add 1. So initially we minus 1, right? Because this value isn't greater than this value. And then, now this value is greater, so add 1. So now we're back to 0. This one's greater, now we've got plus 1. This one's less, minus 1. This one's greater, plus 1. This one's greater, plus 2. This one's greater, plus 3. So we should end up with a plus 3, I think. Should be C. Okay? Once again, just to explain it, we can see that if the value is bigger, we add 1. If not, we minus 1. The value gets updated, this car value gets updated each time with whatever the current one is. So car is here, then car is here, then car is here, then car is here, car is here, and it's compared against the one next to it. Alrighty. Next question. Question 10. Alright, so with question 10, we have let's see. So I'll just flick back to my PowerPoint. Okay, so with question 10, we have different kind of algorithm. We have a loop, but let's have a look. So initially we're setting up the array of length 5. Okay, very good. We are setting the values in this array. So we take a new array, we set the first value to 2, the second value is going to be, I guess, 2 plus 1, because number 0 is 2, and the third value, well actually no, as you see, it uses as a reference here, the reference is the value. So it uses the value as the index. So numbers 0, as we know, was 2. Therefore, the index 2 is going to equal this number. So it's kind of tricking you a little bit, but it's not too hard. Just evaluate them first. Do the inside first, and then work it out. Okay, so it says here for int x equals 3, x plus the numbers dot length, x plus plus, numbers x equals numbers x minus 1 times 2. Okay. So here's the question. Let's get to the question. So this is actually just setting more values in the array. So let's do the question. This one is saying what's going to be the array afterwards. So we know firstly that we have 0 is 2, 1 is 3, and the third value, so numbers square brackets 2, is going to equal to numbers square brackets 1, which is 3. Okay, so we have 2, 3, 3. You see that here? 2, 3, 3, 2, 3, 3. So here we go, C or D. 50-50. Flip a coin? No, let's keep going. So here it says, okay, what's number 3 going to be? Okay, so here we're going to set 3. 3 equals numbers x, which is 3, minus 1, which is 2, multiplied by 2. So numbers 2 we know is 3, and multiplied by 2 is 6. So there we have our answer. 2, 3, 3, 6. And don't even have to work out the last one, because it's going to be 12. Okay? Next one. Question 11. Alright, so question 11 is, again, similar thing. We have a loop running through a list. This time it's an array list. We have a loop running through. Mystery is going to basically say, okay, let's go through. Now, this time, k less than n, so we're not going all the way through our list. K less than n, k equals 0, k less than n, so this is n is the input here. And what we're saying is an object, a new object, equals list.remove 0. So it removes the first item in the list and adds that to the list at the end. So basically, up to a certain number, it's going to remove something from the start of the list and move it to the end of the list. So let's run through it now. So let's say n is 3, for example. We are going to start at 0 and go up to 3, not including 3. So it's going to go 0, 1, 2, this loop, 3 times through the loop. Therefore, we're going to go first time through the loop, we're going to take the 12 and move it to the end. Take the 9 and the next loop, move to the end. Take the 7, move to the end, and that's it. So if I had 3 there, it would move the first 3 items to the end. So let's see this question and see how it runs. Okay, and that's just me explaining what I just said. Okay, let's go through and see this to this run. Okay. So what are our options? So we have this list, and it says what happens. Oh, mystery 3. So we've done that example. So mystery 3, move the 12, move the 9, move the 7. So do you have something with 12, 9, 7 at the end, just like this? All the other numbers are the same. 8, 4, 3, 6, 11, 1. Right, so I would expect it to be D. And there we go. All right, next question. Question 12. Okay, so let's go to question 12. Remove even array list elements. All right, so this one tells you in the title what it's doing. Remove even array list elements. We have a standard algorithm here. We have an array list. We have the remove evens, which takes an argument as a list. And it's saying, okay, let's remove the even numbers. Now, go through the list. This is the for loop, standard for loop. If mylist.getI modulus 2 equals 0. So we've seen this number of times before, where this is how we find even numbers. If it's an even, remove it. And then return mylist. Okay, problem. Is there a problem? Do you notice a problem yet? We're removing from a list and we have a for loop. Okay? This is a problem. Why? Because the index gets messed up when we remove from the list. If you're iterating over a list and you decide to remove something, it's going to get messed up. Okay? Like this. I'm running through this list and I decide, oh, I don't like this value. I'm going to take it away. Bye-bye 7. Now what happens? At position 2 is now 5, And so when I do my loop, I'm moving to the next item and I miss out on dealing with 5 because of the loop. So that's the issue with this one, is it's the problem of removal while you're in the middle of handling an item, right? So you have to fix this by doing it a different way. So this question is just asking you to explain why it doesn't work. So let's find the one that takes that into account. I think it would be this one, is it? E. The code segment skips some elements of my list because the indexes of all subsequent elements change by 1 when a list element is removed. And so that should be E. Okay. So it's in the issue of removal, right, when we're doing that in the list. All right, let's jump on to question 13. All right, here we have a question called remove even array list elements. Well, here we go, another one. So here is a kind of different expression. We're using a loop, okay? So we have an input of an array list, a name, and a new value. And we're meant to be, oh sorry, you know what, this title is wrong. It should be remove even array elements. I think the title is different. Let's check. I think the title should be replacing items in nameless array list, yeah. So ignore the title here. But this is basically saying we're going to replace something. We're missing an expression here, okay? So we do have inputs. We don't have the body of the expression, but we have to figure out what goes there. What's really going there? And what we need to do really in this expression is to be setting whatever name is with new value. So our check here should be if we find this name, then let's set it with this new value. So you just have to basically say, write the statement for that. Okay, so which expression will we need? So, well, we need the Java quick reference, because in the quick reference it does tell us how to compare strings. I would probably use the equals. That would be most likely. But what we're trying to say is if an item in the list matches the input name, right? That's what we're trying to say here. So what is going to work for that? This is a multiple choice question, so let's find the right multiple choice answer. Okay, so we're looking for something that has this expression and equals that thing. Alright, and I think it should be up to you to find which one this is, remembering that with strings you can't do this, which you see in B. You can't say equals equals name. It doesn't work for strings. We're not removing here, we're just trying to look for a match. We can't do equals equals that way. It's an array list, right? This one won't work. This is using a standard array. So no, these are all bad answers. You should be able to see that it's A. We use get J to get the item, and then equals to check if that name string is the same. And so that's why it will be A. Alright, let's jump to question 14. Alright, and alright, question 14. Again, we are traversing a list. This list is given as the input value here. What we're looking at here is we have an array which we need to go through. Now this should be an algorithm that looks familiar to you. You'll notice we have 2 for loops and some code to do some swapping. I hope that tells you something. Well, if it doesn't, the question tells you. The question here, it tells you select sort. So can you guess? We're using selection sort. Alright, so you should know your selection sort by now. Selection sort, how does it work? Okay, let's see. Can I explain? Well, okay, so we have an outer loop which moves through our whole list one by one. Okay, and as that moves one by one, it basically moves the sorted area up one by one each time, right? We're sorting one number at a time. The inner loop is finding the lowest value among the remaining values in the list. Finds the lowest value and then swaps it into that position, the position that had the counter at J, right? So J holds the position, and K goes and searches for a smallest value, and then it swaps it into that J position. So essentially this is what we're doing. And this pos thing is holding the position of the smallest number. Okay, so really, and then we do a swap at the end. But there's an error. It's saying there's an error in this code. And to find the error, you'd really have to know what selection sort's meant to be doing. So all these elements, I mean, like if they're confusing to you, it just means you haven't sort of identified all the elements of how selection sort works. And it works by this position number here, and this is the clue. Pos is where the error is, right? So pos is holding the place of the smallest number. But we don't need to start pos at 0 each time. For pos to start at 0 would mean that, you know, because if you think about selection sort, right? Selection sort works by moving along each time. And as it moves, as J moves, there's a sorted area to the left, which is already sorted. We don't need to worry about that anymore. So each time that the inner loop runs again, it should be starting from where J is, not from 0, which is the start of the array. It should be starting from where J is because that's the start of the unsorted area. So the error here is that pos is in the wrong starting position. It's always comparing. If you start at 0, it's always comparing from the start of the array, which is the smallest value in the array, and it's never going to find a smaller number than the smallest, right? So really, it should be pos equals j, not pos equals 0. So let's go back to our question here. In the choices we've got, what following changes should be made so that select sort will work? So I would say we should be changing it to B, and B would be the correct answer, right? So that's what it should be. B, pos equals j. All right, so I'm going to go and talk about the next one. So let's talk about question 15. Question 15, here are the concepts. Obviously, we're doing some iteration with traversing. We might, well, let's just get to the question now. Write a loop to sum all the values in the input array. Okay, so this is writing a sum thing. Sum, doing a sum is pretty easy actually. Like you can use a regular for loop or an enhanced for loop for this. Very, very simple. Just keep a tally, keep a variable which handles your result, and just add it all up one by one. Very, very simple. So let's see if our question will load for us. I've got a question here. All right. So the question is saying we're missing some code. What should the code be? Well, it's asking us to write the for loop. So we have a few different possibilities here. And let's keep in mind, we have result, we have data is our array. Let's check the for loops at work. So here, k equals 0, k less than data.length, k plus plus, result plus equals k. Seem okay? No, not okay. This is an index. You're adding the sum of the indexes here. We don't want the index. We want the value. We're meant to be adding up the values of these arrays, not the indexes. So using k would be a big mistake. No. Okay, how about here? In D, data, so this is each value of the array, and we go plus equals that. Yes, that works. Lovely. And this one, regular loop, k less than data length, k plus plus, result plus equals data k. Yes, now that works. So 2 and 3 both work. That means that our answer would be E. 2 and 3. And confirmation? Yes. All right. Number 16. Let's do 16. All right, so for question 16, doing something similar. Oh, sorry about that. That was my bad. I didn't show the proper answers. Let me go back a second, because I think I didn't show you the answers here. Let's go back to where I was. 15. I just want to talk through these answers again in case you missed it. The answers were we were choosing the results. This one here was just the index, right? The result plus equals k. These two were adding the values, this value and that value, right? I think I forgot to switch the screens there. All right, let's do question 16. All right, so question 16 is asking us to take a look at this method X. And we have a double for loop. Double loop. Okay, so a nested for loop. Nested loops means that we're finishing this loop every time this runs. So it will run once, here and every single time there, and then another time here and every single time here. So the inside loop gets a lot of work. This, so that's the nested loop there. So we have the inner loop and the outer loop, usually how we refer to them. So what's actually happening here? Well, it's doing a test. If the values k is less than the values j. What is values k, j? Well, k is the inner loop, j is the outer loop. And you notice how k always starts from j plus 1. So it's basically comparing the value and the value greater than it. So for each item in the array, it's going to check and see all of the items that are next to it or coming next. It runs through the array and checks, is the value less than the original value? If it is, it's going to update values j to be values k. So it's going to update all the subsequent values to the value of that number. So it's saying that if the number that was before is greater, update all the subsequent numbers. Okay? Interesting. Let's look at it in the question form and see what we've got to work with here. Alright, so it's saying let's say we have a code segment like this, what's going to be the result? So the problem is that it's saying that if this is, sorry, let's check again. If values k, if the inner loop is less than the outer loop value. So the outer loop value will be here, here. The outer loop value will be here. The inner loop value would be here. And if the outer loop value is, if the inner loop value is less than the outer loop value, then update the outer loop value with the inner loop. So this here is going to get updated with 1, because this is less than this. So it's going to be 1, 1. This is not less than this. This is not less than this. So now we are updated. It just does 1, 1. When we go through the list again, we get to 10. 10 is less than 56, so it will update 56 with 10. So we should end up with 1, 1, 10, 10. And that would be part A. That would be A. Boo, yeah. Okay. All right, question 17. Here we are at 17. I'm going to try and get through all this as fast as I can. I'll do the FRQs in a separate one. Okay, 17. Add and remove letters from ArrayList. It says determine the output value or result of a given program code, given initial values. Determine the results. So this is a practice skill. And this is going to require you to be able to use these ArrayList methods, add and remove. So it's really testing your skill and be able to use the Java's quick reference methods. All right, so let's have a reminder of how they work. Add. Now you do get these in the exam, so you can refer to them. You have to remember them, but you should remember how to use them. And add, you give an object, and it will give you a true or false result. If it adds to the end of the list successfully, it'll say true. Okay, the add will take an index and an object and add to the list at that index. It doesn't return anything. And remove will remove whatever's at index, whatever's at that index. It will decrease the index of all the subsequent values. The key is to remember that it also returns the object that it's removing. So you can actually take that object that it's removing and use it for something else. It returns it. So that's the interesting part of that. Okay, so we're really trying to use these to add and remove ones here. So let's have a look and go and try and do some adding and removing. Alright, so we start with an empty array list of strings. We add A, we add B, we add C. Now, we add, at position 0, we add D. So now we should have D, A, B, C. Then we say remove 3. Alright, so what's it, 3? 0, 1, 2, 3 would be the fourth one. That would be C. So now we have D, A, B. Now we add at position 0, E. So now we have E, D, B, C. E, D, A, B. And that's it. E, D, A, B. Oh, there we are. E, D, A, B. Bingo. Right? So it's just your knowledge of how does this work, how does it work when you do it, does it remove, does it overwrite? No, it just adds it, and the others get moved along. Alrighty. 18. Alright, so here we have another algorithm. Let's take a kind of a closer look at it. Alright, so we have this one is add and remove letters from ArrayList. No, I think that's probably not the right one. I think that's the same as the last one. Let's update the title again. But this is using Insertion Sort. Okay? So, Insertion Sort, if you remember, it works by taking the next value and saying, oh, where can I put this? It searches backwards until it finds a place to put it, and then it will put it in there, right? So Insertion Sort is basically working, going backwards. Now, it doesn't know necessarily, Insertion Sort doesn't know where it's going to end up. So it can't use a for loop because a for loop is, it kind of knows where it's going to end up. If you look at the example here, it starts and says, okay, 4, it's sorted. Okay, now 3, where does 3 go? 3 goes before 4. Where does 2 go? 2 goes before 3. 10, where does 10 go? It stays where it is. 12, where does 12 go? It stays where it is. 1, where does 1 go? Oh, it goes all the way before 2. It doesn't know how far it's going to move these values back. So for that, you need a while loop, because you don't know how many it is. Alright, so the question here is, we have to try and figure out how am I moving things backwards. This array list, here, the example here is we got at the start. Let's focus on the question. Okay, the question is, what will the contents of data be after 3 passes of the outside loop? Right? What will the contents be after 3 passes of the outside loop? Are you in j equals 3? Okay. So we're trying to look at this, okay, from the start. How does Insertion Sort work? This is all it's asking you really to do, is figure out how Insertion Sort works. And so we would say, okay, we take the 2, move it back. That's the first loop. Then, so after one round, we end up with 2, 5, 4, 1, 3, 6. Then we say, okay, take the 4 and move it back as well. So then our next value we move back. And so on and so on and so on. So we're just moving it back. We end up with, after 3 loops, 1, 2, 4, 5, 3, 6. And let's see, where is that? 1, 2, 4, 5, 3, 6. Looks like it's C, is it? 1, 2, 4, 5, 3, 6. Yep. Okay, so just knowing how Insertion Sort works. Okay. Important to note that, I mean, part of the process of doing the Insertion Sort is that the for loop is going forward, the while loop is going backwards. Okay, question 19. Here we're counting how many times things get executed, and it's doing an Insertion Sort again. The key with this is to say, okay, how many times will K get run? the important thing is that we look at, we set k equals, if you notice J is position 1, which is number 2, and k is going to get set to J in the beginning, right? And it's saying, how many times will this get executed, this get executed? This question is interesting because when you look at what the statement is, the only time this statement will run is either if k is greater than 0, well, that's fine. But also if v is less than data get minus 1. So if the value of the in a position of J is less than this one, which is k, and it's saying that if the list has an element that's got one number that's greater than a previous number. So while this is less, so while the value here is less than the value here, and in such a list that doesn't happen. Like the value here is not less than this one, the value here is not less than this one, the value here is not less than this one. So in this case it doesn't really work. This inner loop doesn't get run. The outer loop will get run every single time for the J to move along. 1, 2, 3, 4, 5. So the answer would be, for this one, 5 and 0. Okay. So let's check that out on the question. All right, and oops. Yeah, so 5 and 0. What are we saying? Statement 1 is the inner loop, right? Statement 1 is here in the inner loop. This won't get run. So 0 for statement 1 and 5 for the outward. So it would be B. Check it. Yes. All right. I think we got one more left. Is it one more? 2 more. So let's do the next one. Okay, 20. Sort method with string array. So this time we're going to be sorting with a string. And it's going to track and see what happens when we do a couple of different passes of this sort. So we have a string array, and we start at the end and move backwards. Okay. Pass equals just the index of the last value, and we're going to keep going till we're greater than or equal to 1, not 0. Interesting. This one's going to get to 0. This is going to start at 0. So this one's going the other way. As you see, this is a sorting algorithm. It's going in opposite directions. So what happens here? Well, so we start at last value, go backwards. Look up the largest value from 0 up to pass. If you find a large value, you move it to that position. Right? So it's going through and trying to compare the values to see if it can switch it. So, it has the swap here. 2 4s and a swap. Which kind of sort do you think it might be? Selection sort? I think maybe. The only difference is that it's doing it in reverse. Okay, so it's starting at the end. So let's take, for example, what's happening here. So string large array 0, that's large is well, large would be, in this case, N. Okay, but pass is Bill, because the pass is set to the end. Okay, so now string large equals, so we have the large is the first value, index equals 0, and for 0 to less than pass, k plus plus. Okay, so we're going to go up until the value of pass, which is the end of the list. So up to Bill, let's see if we can find the largest value, right? It's looking for the largest value among all these things here. So what do you guess it finds as the largest value? Well, it's probably going to be Walt the first time. The largest value is Walt. So at the end, we're going to swap that value with Bill. Right? So Bill and Walt get their positions swapped. Next time around, our value of pass is Mary, and we're going to look for the next biggest one, which would turn out to be probably Shari. And then Shari would swap with Mary. Okay? Not too complicated there. Right? So again, we have an inner loop, outer loop, and yeah, you should be sort of like identifying the selection sort and how it's working by now. All right, I think we've got one more question of these multiple choice. Oh, well, I didn't answer the question, did I? Okay, let's go through and answer the question. I think the answer should be we had Bill, right? Bill and, no, what was it? It was, Walt gets moved to the end and Bill gets put here, right? So don't forget, when they swap, they exchange the position. So Bill should be Ann, Mike, Bill, Lisa, Mary, Jose, and then I would say Walt, Shari and Walt. So, which one's that? I think that's it. So, there we are. We're at the final question. Final question, 21. Okay, 21. Let's go to the question here quickly. All right, array list of colors. So we are trying to figure out what's going to be printed, and this is really just an issue of you being able to work out what's happening with these standard methods here. So we have an empty list. We add red, so now we have red. We add orange, now we have red-orange. We set 1 to yellow. Now we've exchanged orange, now it's yellow at position 1. Add green, now we have red, yellow, green. Red, green, yellow. And then we have set colors size -1, blue. Well, the color size is 3, -1 is 2, so set 2 to be blue. That replaces yellow. Now it's red, green, blue. And then we remove the 0 one. So we're removing red. So in the end, it's green and blue. And that's it. Okay. Thank you, everybody. Okay, that's some pretty good answers there. So I'll do the FIQ, I think, in a separate one, so it's a little bit cleaner. Okay, thank you. Bye.